Hey everybody, today you are going to be learning how to graph polynomial functions in factored form. So we are graphing in factored form. So this is a little bit different than when you graphed last week. So if you remember last week, you graphed in standard form. So you picked 3 numbers for x, you plugged them in, you got out some numbers for y, you plotted those points, and then you connected them depending on the degree and leading coefficient. So today what we're going to do is we're going to plot the x-intercepts and use those points to help us graph the polynomial function. The only thing is that at an x-intercept, 3 different things can happen. And hopefully you kind of saw those 3 different things happening when you typed in all those graphs that I gave you onto Desmos, which is what you should have done just before watching this video. So we're looking at 3 different things that can happen, and they all depend on what the exponent is in that factored form of an equation. So if you look at example 1, this is an example of a factored form of your function. It hasn't been FOILed out or multiplied out. So this is the graph of f of x equaling x minus 4 and times x minus 1. So the x-intercepts are at 4 and at 1. So you can see over here I did a little bit of work where I factored for you and showed you, if you were to set these equal to 0, you would get 4 and 1. So we know that the graph passes through the x-intercept at 4 and 1. Now, because the exponent of those expressions was 1, meaning there's only one of them, we say that those zeros have a multiplicity of 1. So hopefully what you saw when you were graphing is that anytime you have an expression that has a multiplicity of 1, all right, a real 0 with a multiplicity of 1 should pass straight through the x-intercept. So it just goes right through at 4 and right through at 1. It doesn't do anything else at the 0 except just pass straight through. The second thing that can happen at a 0 is we can kind of just bounce off of the 0. You can kind of touch it and then it goes back off in the other direction. That happens when in your factored form you have an exponent of 2, meaning that 0 has a multiplicity of 2. So again, hopefully when you were graphing on Desmos just before this video, you could see that anytime you had an expression to the second power, at that 0, it bumped off of it and kind of just kept going in the other direction. So if you look at the example I gave you, okay, it's like, let's say you factored this expression, you would get x equals 3 and x equals 3. So we're saying that x equals 3, and now we're talking about a multiplicity of 2. So in factored form, you would see it look like this, x minus 3 to the second power. The 0 produced by x minus 3 is 3, and because it's to the second power, it approaches and touches 3, but then it bounces back off in the other direction. So what we say is that a 0 of multiplicity 2 just touches the x-axis and bounces off. It doesn't actually pass through the x-intercept. The third thing that can happen with a 0 is when you have a multiplicity of 3. So this time, let's say your factored form, you have an exponent of 3. So we've got an expression, but now it's to the third power. So again, when you were playing around with Desmos, hopefully anytime you saw an expression that was to the third power, you kind of noticed that it did go through at that, but it almost kind of laid flat before going through. So in this third example, if you're given x minus 3 to the third power, our 0 is still at 3, but because it's to the third power, it's going to approach it, lay flat at the 0, and then pass through. So we say that a real 0 of multiplicity 3 passes through the x-intercept with a curve, or it kind of just lays flat before actually passing through. So these are kind of 2 definitions of what happens. So again, just to kind of recap, 3 things can happen when you have a graph touching an x-intercept. It can pass straight through if the exponent of the expression is 1. It can just touch it and bounce back off in the other direction if the exponent of that expression was 2. and it can lay flat before totally passing through if its exponent of the expression was 3. So what we're going to do on the back is we're going to kind of combine all 3 of these together. And so maybe you have a graph that passes straight through at 1, 0, it just touches another, and then maybe it kind of lays flat while going through another 0. So in the second video, I'm going to go through the back of these notes, and which are the examples. So you want to go ahead and now watch the second video and fill in the back of these notes.